Okay, this is section 6.7, linear systems. Mike wants to join a ski club for the winter season. He's considering the two options shown. Which payment option should Mike choose? So he's got the option of standard rate or frequent extremis rate. What type of variation would you say standard rate is? Yeah, Max.
Direct rate.
Yeah, direct, right? Because there's no direct variation because there's only a variable rate. And this appropriately would be indirect. Okay, how can you use linear systems to solve problems? Refer to the information above. Write an equation that relates the total cost, C, in dollars, and the number of days, N, that Mike goes skiing if he chooses the standard rate. Okay, so here's our total cost. C is going to be equal to, what value am I going to use here for slope? Hugo?
50.
Right, 50 N. And is there a B value?
No.
No. Okay, good. So this is the standard. This is the first one. Second one, our cost is going to be equal to, Sal?
100D plus 40.
Close.
100
Yeah, no, Tim?
40 and plus 100.
Yeah, because it's 40 per day, right?
Nice.
Plus 100. All right, there's our two formulas. Direct or partial, we talked about that already. We know that the first one is direct, the second one is partial. 3 says graph both linear relations on the same grid. Use two different colors, one for each line. Clearly label each line with its equation. This combined graph illustrates a linear system. So, number of days. Again, we'll use a maximum of, say, 7 days. There's 7 days. And then cost, if it's $50 per day, 7 times 50 is going to be 350, say 500. 1, 2, 3, 4, 5. There's our cost and there's our days. Okay, so two lines. The first one is 50N. So in 7 days, it's going to cost 350. So 1, 2, 350, and 7. So there's one line. This is C equals 50N. The next line is 40N plus 10. So 280 plus 100 is 380. Hmm. 380. That's very similar. Let's see if I can do it. This is C equals 40N plus 100. Any questions about this graph? It's a little small. Let's zoom in here. So we can see that one has a bit of a steeper slope, and they will meet at some point. Looks like it's after 7 days, though.
Yeah, it's gonna be 10.
10. Okay, you're already ahead of me. All right. So let's see. Graph both linear relations on the same grid. Use two different colors, one for each line. Clearly label. So that's our linear system. Look at the point where the two lines cross. This is called the point of intersection. So this is going to be somewhere up over here. Okay? People are saying it's 10. We'll find out. What is the value of n at this point? Okay, so it looks like 7, 8, 9. Looks like 9 on my graph. We can find out. How can we find out? You substitute in the value of 10, we get 500. Value of 10 here, we get 500. So very good. They figured that out by substituting in a value of 10 for n and solving. There's another way to find that out. Anybody know? Yeah, Tyler?
Well, for the second deal, it's saving you $10, so I just thought to myself, how many weeks would he have to go until like it pays off 100? So if he stays anything over 10 weeks, or 10 days, then he's basically getting a deal because he's paying $10 less each time. But if anything, if he goes under 10 days, then
Yeah, so you reasoned it out logically. Good. So that would work. There's another way, actually, algebraically. You don't have to think that hard. Anybody know? I can set the yeah, AJ.
Could you plug in the 500?
Yeah, but you don't know it's 500 yet, right? So here's what we can do. We can actually set the cost equal algebraically, right? And solve for the number of days. So I can take this value and set it equal to this value because I'm setting the cost 1 the same as cost 2. So if I do that, let's do that up here. Cost 1 is equal to cost 2. So we want to know when are these two costs the same, right? At what day? So now we substitute in 50n for cost 1 and 40n plus 100 for cost 2. Now the 40n comes over, we get 10n is equal to 100, n is equal to 10. You see that? Yeah, so it's very easy. You don't have to think about anything, you just make the cost the same. Okay? Look at the point, this is called the point of intersection. What is the value of n at this point? So we said 10. Look at the left. Look to the left of the point of intersection. Which plan is cheaper? Explain how you know. So the left of the point of intersection, which one's cheaper? The blue one or the pencil color? Adam? Blue. And this is the direct or indirect?
direct.
Yeah, direct. So the standard rate. The standard rate is cheaper if you go less than 10 days. Yep.
How would you solve the top equation if it didn't exactly equal 500, if it wasn't even? Like if it was $101? Because then it'd be like
So
7.
it could have been like this, right? 50n is equal to, say, 41.
Yeah,
41n plus 100.
yeah.
Yeah? You would have just done 9n equals 100. N is equal to 100 divided by 9. Okay? All right. So we know the standard is cheaper. How do we know? Because the cost in dollars is always lower. That's how we know. Because here's our cost. It's lower on the y-axis. So lower on graph. That's how we know. Look at the right of the point. Which plan is cheaper? Explain how you know. So if we go to the right, you can imagine that these are going to intersect like this. Right? If this is 10 days here. Here's our cost. Here's our days. Here's our 10 days. This point here, we can see that the indirect variation graph is going to be lower. So in this case, it would be the frequent extremist is lower cost. Everyone understands that? When the two lines intersect, which one costs more? Well, it's going to be the higher one, obviously, if the y-axis is cost. Everyone get that? AJ?
But wouldn't that depend on how long you're going to be going for? Or how many times?
Yeah, it does. So before 10 days, the direct is cheaper, and after 10 days, the indirect is cheaper. It does depend on time, right? Because once it passes this point, you see how they flip, they switch, right?
Yeah.
You guys see, that's what I'm trying to show here, right? Indirect cheaper here. Sorry, indirect cheaper here, direct cheaper here, right?
So what if on the test we get a line like that and it just says which line is cheaper? What would we answer?
No, it would depend on the day. You would say this line is cheaper up until 10 days, and then this line is cheaper up until after, okay? Find the cost of both plans at the point of intersection. What does this mean? So what is the cost of both plans at the point where they cross. Who knows how to do that? Christian at the back.
The cost of both plans.
At the point of intersection, yeah.
Well, we could just like use the graph and just like line it up, or we can the equation.
You're right. So we could use the graph. We could go to this point and run across and say, well, it looks like 500. You're good. You're right. Or how else could we do it?
Well, we did it like a few minutes ago, where we put both equations, so like 50 n and then 40 n plus 100 on both sides of the equal signs, and then you solve for n.
No, that gives us the number of days. We're looking for the cost when they're equal.
You plug in the number of days into both equations.
Excellent. Yeah, that's it. So would you have to plug it into both or just one?
We need to do both to make sure both of them are equal 500.
Well, assuming you knew what you were doing with your math, then you shouldn't have to do both, right? Because you've proven it here, it's 10 days. You take that value and you sub it in to 50n, so our cost is 50 times 10, which is 500. Okay, we'll do the other cost just to be certain. 500. Any questions there? All right. Is one of the two payment options clearly better than the other? Explain what additional information a skier or snowboarder needs to know to choose between the two. So this is kind of what AJ was getting at. So what do we need to know to choose between them, Sebastian?
Pardon, sir?
Which plan's better?
Oh, which plan's better? It depends on the day. So if, let's say it's 5 days, the first plan's better. If it's after 10 days, then the second plan's better.
You got it. Perfect answer. A solution to a linear system of two equations is a point or a set of points that satisfy both equations. There's three different types of solutions. So two parallel lines. It's still called a system of linear equations. System of linear equations, remember what that means. It just means two or more lines. It's got a fancy name, but it means two or more lines that you're considering at the same time. If they are parallel, there's no solution to that system because there's nowhere that they cross. Okay? So that's important to know. These lines never cross. There is no point that satisfies both equations. There's no solution. Okay, that's one scenario. The second scenario, when they're non-parallel. So they do cross. Of course, they're straight lines. So are they ever going to cross again after they cross that one time? No, because they go on forever in either direction. So there's only one solution. And finally, the last scenario is if the lines themselves are the exact same line. They're exactly on top of each other. They drew two graphs here just because if they drew one graph, it would just look like this. The line would be right on top of itself, okay? So although this equation looks different from this equation, you can see if you divide everything by 2 here, you get the same equation as here, okay? So you need to be aware of that if you have an equation, say, in standard form, remember which is capital A x plus capital B y plus capital C equals 0, and you have equation of a line form, y equals mx plus b, you might not know that they're actually the same line until you rearrange one. So it matches the other, right? If you come into that scenario where you rearrange it and it's the exact same line, there's an infinite number of solutions to that linear system. Remember what that means. A solution to a linear system is where the lines touch. If they're the same line, then they're touching on every single point. So there's an infinite number of solutions. If they cross at one point, there's one solution, that point. That's going to be what we're focusing on. And if they have the same slope, of course, they don't cross at all. So there's no solutions. Okay? Robert, can you just recap that, the 3 scenarios?
So there's the ones where the lines never touch, the
Right.
parallel lines.
Yep. How many solutions?
Pardon?
How many solutions for that example?
0.
Good.
Then there are 2 non-parallel lines,
Right?
and they intersect at 1 and 1. Sorry, no. For that example, that's where the lines intersect.
How many solutions?
one
Good.
solution.
Good.
And then there are two identical lines,
Right? How many solutions?
and there are an infinite number of solutions.
Excellent. All right, example 1. Graph the following lines on the same grid and identify the coordinates of the point of intersection. So here's a scenario where we're given two lines. One is in standard form, and one is in y equals mx plus b form. So they might be the same line. We got to be careful. So the first equation is in slope y-intercept form. The slope is a half, and y-intercept is -3. Use this information to graph the line. So we do that. We graph that line. The form of the second equation is easy, makes it easy to determine its x and y intercepts, and we use them to graph the line. So rather than converting to y-intercept form, which I probably would have done, to be honest, they actually just used the x and y intercepts, substituted in a value of 0 for y to solve for x, 0 for x to solve for y, and they got these 2 points here, here and here, okay? And you can clearly see then that these are two separate lines that intersect at one point, right here. Okay? The two lines intersect at point -2, -4. This is the solution to the linear system. So it's where they intersect. All right? Yeah.
So you know how you were doing that to see what point they would meet at? Could we do that with this if we were to put in y-intercept form?
That's exactly right. Yes, you could.
And so how would you?
All right, so if we wanted to do it that way, let's just back up. So very good observation, Tyler. He said, let's put this one into y-intercept form. So this is going to be y equals -x minus 6. Everybody agree with that? Now we have two in the same form. We can see that their slopes are different, so they're not the same line. If we set both of these equal now, so we say -x minus 6 is equal to 1/2 x minus 3, we can solve for the x value of where they intercept. So we're saying that the y value is the same, so we're setting those two y values equal and solving for the x value. Once we get the x value, we can sub that back into either equation to get the y value, and that'll give us the point of intersection. Does that make sense? Yes? Anyone confused?
Could you solve it?
Hands up. To solve it, okay. To solve it, there's a fraction, so we'll want to multiply everything by 2 to get rid of that fraction. So here's what we get. Everybody see that? 2 times -1x is -2. Oh, my bad. -2x. -6 times 2 is -12. Equals 1/2 times 2, right, is 1. So we just left with 1x. And then -3 times 2 is -6. Any questions there? All right, now we want to put all the x values to the left. So this x is going to move over. We're going to end up with -3x. Move the integers to the right. That becomes +12 minus 6 is going to be 6. Now we divide by -3. X is equal to -2. So if x is -2, I can take that value now and sub it back into either equation. We'll use the one without a fraction. Sub it into x here, and I get -2 plus y is equal to -6. Y is equal to -4. So my point of intersection then, -2, -4. Any questions? Yeah.
When you have a fraction comparing both of them and you want them to be equal, do you have to get it to a whole number?
No, you could work in fractions.
Okay.
You don't have to.
What about decimals?
Yeah, you can work in decimals if you know what you're doing. It's a good idea to just multiply the fraction out, though. Believe me, it's a lot easier that way. So we got the same value here, -2, -4. This is the solution. So finally, the last one, B. Here's our question. Verify your solution that satisfies both equations. So the way we verify is we plug in the value. We plug in the value and check if the left side equals the right side. So for the first equation, we're going to plug in -4 for y, nothing else to do. There's -4. And then we plug in on the other side -2 for x, and we solve and make sure that the left side equals the right side. That'll make sure that that particular point is on the line. We do the same thing with the other equation. Plugging in on the left side, we end up with -6, and the right side is already -6, so we know that these 2 points, this one point satisfies this equation, and it also satisfies this equation. So we know that that's the point of intersection. Any questions? Therefore, the point satisfies the equation. The point -2, -4 satisfies both equations. -2 and -4 is the correct solution to the linear system. We're just going to finish here, guys. Give me 2 minutes. This last example, you use a graphing calculator, which we're not going to do. So finally, the key concepts. A linear system is 2 or more linear equations considered together. The solution of a linear system of 2 equations is the point at which their graphs intersect. The coordinates of a solution must satisfy both equations. That's it.